Dear students, let us begin with our second part of the lesson, in which you will learn about the finding the expected frequencies using regression models. So before entering, you have to know what is a regression model. A regression model is a statistical approach used to examine the relationship between one or more independent variables and a dependent variable. As you know, the base that you need to have a correlation between the variables, then you can identify the dependency among them. The goal of a regression model is to understand and quantify how changes in the independent variables are associated with changes in the dependent variable. Here the numbers will specify the nature, how it has been associating with respect to the dependent variable based on the independent variables. Let us can go for some examples. Age, height, where you can see the variable has been related. First of all, you know that our age will be increasing, automatically the height will increases. You can see a sample graph in our hospitals, wherever you go for a children hospitals, where you can see a graph that while age increases, the height will automatically increases. Similarly, income, expenditure, as you know that which is highly correlated, that depending upon your income you will be deciding your expenditure. Then demand and supply, where based upon the demand the supply will be decided. Here you are able to find the relation between them, and also you have to think about dependency nature. Here which variable is depending on which variable, you have to think of these. So here in these examples, age and height, here you can see about the dependency nature also. It has been related already, you have to think about the dependency nature. So here your height is purely dependent on age. Similarly, your expenditure is purely dependent on income. Similarly, the supply will be dependent on demand. So you have to identify which variable is dependent on the which one. So in correlation you are able to identify the relationship between the variables, whereas in a regression you are able to identify the dependency nature, which one is depending on which one. Now we can go with the linear regression model. As you know that it is a statistical model that examines the linear relationship between a dependent variable and one or more independent variables. It assumes that the relationship between the variables can be represented by a straight line. So here in a mathematical format, y equal to mx plus c will be your straight line equation. So here in a statistical pattern you will be moving on as y equal to a plus bx, that is y will be called as dependent variable, x will be called as independent variable, your small a and small b will called as parameters. You can see our text here. Similarly, in a straight line equation, y equal to mx plus c, m will be acting as a slope and c will be acting as an intercept. The same format here you have been chosen, the m is nothing but the b here, similarly a is nothing but your c here, that is what you have been represented. Here a and b also known as the parameters of linear regression. Statistically you will be calling a and b as the parameters of linear regression. Now the fitted form of a linear regression model will be y cap equal to a cap plus b cap into x, whereas your a cap and b cap will be estimated through the method of least squares. So you can understand here y cap will be acting as a dependent variable again, but you can call it as expected frequencies. Earlier your y is dependent variable and can be called as observed frequencies, whereas now here it is called as expected frequencies. Whereas your a cap and b cap can call as estimated parameters. Earlier a and b are called as parameters, now it has been called as estimated parameters. So these parameters can be computed by method of least squares. The method of least squares will be nothing but the summation of the error. Now you can go for, generally for each parameter a normal equation will be derived. So here we will obtain two normal equations because we have two parameters a and b, small a and small b. So we are having two different normal equations. So by simplifying them, the parameters a and b will be estimated. Method of least squares is a technique to identify the parameters of the linear regression model. The residual sum of squares, that is RSS, will be represented as summation yi minus a minus bxi whole square. So here it has been obtained from your linear equation as it is, but whereas you are taking it as an sum of the residual is nothing but the yi minus a minus bxi is the residual and square. That is what you are using the word as an residual sum of squares. By partially differentiating the above equation with respect to the parameters a and b and equating them to 0, we can obtain two different equations where you can call them as normal equations. Now here you can see the first partial differential equation. As you know that the partial differentiation can be considered as dou, that is dou RSS by dou A. So dou of your summation of yi minus a minus b xi whole square by dou A will be equivalent to 0. By simplifying this equation, you can obtain a normal equation as here summation yi minus n into a minus b into summation xi equal to 0, whereas here n represents number of observations. Similarly, we are going for the second partial differential equation with respect to the second parameter b, dou RSS by dou b, you can see over here. Now dou of summation yi minus a minus b xi whole square by dou b equivalent to 0. By partially differentiating this equation with respect to b, you can obtain the second normal equation as summation xi into yi minus a into summation xi minus b into summation xi square equivalent to 0, which will be your second normal equation. So there must be a gap between these y and y cap, that is y is your observed frequency and y cap is your expected frequency. So with respect to your earlier two equations, you can solve the two equations and you can obtain your parameters a and b, and you can fit the equations into the y cap, that is your a cap and b cap. So with that you can see some gap between them, that is nothing but the difference here, where it means there will be a gap between observed and expected frequency. Then you can fix your hypothesis as there is no significant difference between observed and expected frequency, that is your H0 null hypothesis. Then in your H1 alternative hypothesis, definitely you can go with there is a significant difference between observed and expected frequency. Now you can see with the sample data here, I have been chosen capital X as monthly kilowatt, and similarly monthly bill observed frequency as OI capital Y here. So here these are all represents the number of units you have been used, and here it has been the amount which you have been considered. Similarly, it is nothing but your expected frequency. By simplifying your A cap and B cap here, you can get these values. Yes, I can show how it has been obtained here. For the above data, on simplifying normal equations, the derived through least squares method, you will getting A cap and B cap as 20 and 0.15 respectively. By fitting this equation, you can say that capital Y will be equivalent to 20 plus 0.15 into x, which is your fitted linear model. By substituting your observed frequencies, that is 300, 400, 500, 600, 700, 800 in the above fitted linear regression, we can obtain the respective expected frequencies as example here, y cap will be equivalent to 20 plus 0.15 into x, the x is nothing but 300, the value is 65. Similarly, you can calculate all the values of your expected frequencies by substituting the remaining 400, 500, 600, 700 and 800. Now automatically you can see a gap between them, that is your y and y cap. To study the gap between them, observed and expected frequency for the above data, one has to go for chi-square test using regression models. So the values of y will be treated as observed frequency OI, and the values of y cap will be treated as expected frequency EI. Then the chi-square statistic will be computed using the formula summation OI minus EI whole square by EI, where you can see the formula over here. By comparing the calculated value and critical value, we will go for the decision on the hypothesis acceptance. So you may be accepting or you may be rejecting it. Dear students, we come to the end of part 2 of this lesson. In this part 2, we have learnt on the computation of expected frequencies through the regression model with an example problem. I am confident that you understood all the concepts and the problem solved over here. We will continue in the next video. Thank you.